Assalamualaikum to all panelists and viewers of my video presentation. First of all, my name is Danial Erffan bin Mohamad Nasir. I will present to you my final year project proposal titled Design and Fabrication of Thermoelectric Generator that Converts Waste Heat Energy to Electrical Energy. This project is under supervision of Dr. Fauziah Jerai alias Junaidi. Let's go through the outlines of this presentation. This presentation includes project summary, introduction, literature review, problem statement, objective, scope of work, methodology, expected results, and project planning. Firstly, let's look into the project summary. The thermoelectric generator TEG is a device that converts heat energy into electrical energy. TEG employs the Seebeck effects concept to generate energy across its connection when the temperature change. In this project, a TEG prototype will be built to calculate the quantity of electrical energy generated with different temperature. This prototype will calculate the quantity of electrical energy by the waste heat. Thermoelectric generators also have a significant benefit over other types of power generators in that they are low maintenance, lightweight, noise-free, and pollution-free. Next, introduction. A thermoelectric generator TEG, also recognized as a Seebeck generator, is a solid system that effectively turns thermal flux into power through the use of a method called the Seebeck effect. Basically, it's a thermocouple-based generator that transforms thermal energy into a new source of electricity through temperature difference. Thermoelectric generator development consists of three major components: thermoelectric materials, thermoelectric modules, and thermoelectric heat source interfacing system. Thermoelectric materials instantly generate energy from the heat by incorporating temperature differences into electrical output. These materials must have both high electrical conductivity and low heat conductivity to be good thermoelectric materials. A thermoelectrical system creates electricity by transferring heat from source such as hot exhaust flue. A thermoelectric module is a circuit that contains thermoelectric materials including N and P-type semiconductor. In a P-type semiconductor, an impurity adds additional holes, known as acceptor atoms, whereas in an N-type semiconductor, an impurity adds extra electrons, known as donor atoms. Now, let's go to the literature review. Thermoelectric generator. TEGs are a solid semiconductor device that transform temperature and heat flux variation into a useful DC source. The Seebeck effect is used to power the thermoelectric generator. Voltage were created when two junctions are created by connecting two dissimilar metals sustained at different temperature. The output power generated depends on the temperature difference between two different junctions, and this is called a thermocouple. The thermoelectric voltage generated is determined by the metal used and the temperature difference between the junctions. Due to the movement of charge carriers, the Seebeck effect arises inside the semiconductors. If the two junctions have the same temperature, the voltage produced at each junction cancel each other out and no current flows through the circuit. Next, Seebeck effect. The Seebeck effect was named after Thomas Johann Seebeck, a German scientist who discovered it in 1826. A temperature differential between two dissimilar electrical conductors or semiconductors causes the Seebeck effect, which results in a voltage difference between the two substances. The pair of metals forming the circuit is called a thermocouple. If the two junctions are held at different temperature and two dissimilar metal wires are connected at two ends to form a loop, a voltage is produced in the circuit. The current is flowing from the hot junction to the cold junction. Electrons move from warmer end to cooler end, which result in energy transportation and temperature equilibration. A negative thermoelectric EMF is created in the wire with regard to the hot end when electrons diffuse from the hot end to the cold end, and positive thermoelectric EMF is created when electrons diffuse from cold to hot end. Lastly, thermocouple. Thermocouple is a temperature sensor which are widely used in industrial environments and lab tests. Thermocouple acts as a transducer that processes thermal energy into electrical energy. It is made up of two dissimilar semiconductors that form hot and cold junctions. The electromotive force EMF is created by keeping two junctions at different temperatures. The thermoelectric generator uses thermocouple for its accurate measurement. Each thermocouple is made up of P-type and N-type semiconductor. The P-type and N-type of the thermoelectricity components were connected using metallic electrode at the hot end. A thermocouple generates a very low voltage that is measured in millivolts. In reality, the body generates a millivolt signal that is greater than that of a thermocouple. Next, problem statement. There are three problem statements for this project. From the monitoring point of view of the aviation sector, the energy loss or waste heat energy released by the turbine engine exhaust is in an aircraft is wasted and not used in the environment. This will increase greenhouse gas emission and make a greater contribution to global warming. The first problem statement is energy loss is released by exhaust of engine and not efficiently utilized. Second, efficiencies of powers are limited and must burn more fuel to reach desired output which damage the environment. Lastly, this project aims to develop an alternative device to fabricate energy from waste heat. In order to solve and overcome the problem of the TEG, the project must meet the three following objectives. Objective number one, to design a fully functional portable power or device that can utilize heat energy wasted. To produce a portable power device that can be used as a backup power source. And number three, to investigate TEG's performance in different heat energy source and cooling system. For scope of the study, this project will focus on the amount of electricity power produced by thermoelectric generator which comprise of three major components which are energy harvesting, power management, and power consumption. The modeling and design of the generator will be done by using SolidWorks software. The parameters involved are voltage, match load resistance, output power, output current, heat flow through module, and heat flux density. The limitation of the study is to investigate the TEG in which the detailed product specification should be verified beforehand, especially in terms of its temperature limits and power generation capacity in order to properly convert those information into actual working design. For the next part, I will present the methodology of the project. Figure 3 shows the flowchart of the project. The first method is literature review. Studies were conducted in order to collect data and they were based on article reference as a literature review. The study is to review past research on thermoelectric generator design and characteristic. Secondly, defining the problem and the scope of the projects. Identifying the objective and solution for the problem of the project. The table for the research framework of the project is presented below. Thirdly, determining the applicable shape and design of the thermoelectric generator by using SolidWorks software. SolidWorks is a three-dimensional implementation of the product. This is a program that runs on Windows Computer Aided Design CAD system. Figure shows the design that were made in SolidWorks. Next method is data gathering and analysis. The temperature and voltage generated are gathered to do analysis. The final method for this project is fabrication. The fabrication will be done in the next semester. There are a few equipment used for this project which are heat blower, Arduino Uno, stopwatch, power bank, and USB port. Next, expected results. The TEG will be fabricated based on the design simulated in SolidWorks. The produced results are temperature and voltage generated. The relationship between temperature of the heat supplies and the value of voltage generated will be demonstrated using charts and graphs. How does different temperature affects the amount of voltage generated will be discussed. And finally, project planning. Table shows the project activities for final year project 1 and final year project 2. That's all from me. Thank you.